This is our planet, planet Earth. It contains an astonishing variety of landscapes and climates. Since life began around 4,000 million years ago, it has gone through extraordinary changes in its climate and in the species that live on it. But now it seems that our planet is being transformed, not by natural events, but by the actions of one species, mankind.
You and I belong to the most widespread and dominant species of animal on Earth. We live on
27 years ago, I presented Life on Earth, a series that traced the evolution of life from its very beginnings. I set out to find and film representative species of the whole animal kingdom in all its marvelous and wonderful variety. In the final program, I dealt with the arrival of human beings, still a recent event in the history of our planet.
There is no scientific evidence whatsoever to suppose, indeed, that man's stay on Earth should be any longer than that of the dinosaurs. But although denying a special place in the world may be becoming immodest, the fact remains that man has an unprecedented control over the world and everything in it. And so, whether he likes it or not, what happens next is very largely up to him.
Up to us, indeed. At the time I spoke those words, I had no idea that we, mankind, might have unleashed forces that are now altering the climate of the Earth. Could the destruction of towns and cities in the southern United States be linked to the collapse of glaciers in Greenland?
I lost everything. Everything.
Everything's gone. People, furniture, and stuff floating around. It's real bad.
Might drought in the Amazon that killed thousands of fish be connected to the intensity of forest fires in Australia? And are these events related to one of Europe's hottest ever summers, which led to the death of 27,000 people? In every part of the world, new climatic extremes are now being recorded. Our weather is in turmoil. During the last 50 years, I've been lucky enough to spend my time traveling around the world, looking at its wonders and its splendors. During that time, of course, I've seen many changes, some good, many bad. But it's only in the last decade that I've come to think about the question as to whether or not what I or anybody else has been doing could have contributed to the change in the climate of the planet that is undoubtedly taking place. In recent years, scientists have been collaborating on one of the most urgent and ambitious endeavors in our history. They're trying to understand the unprecedented changes in our climate. And they're linking those changes to the rising temperatures that they're measuring at thousands of weather stations around the world. So how much have global temperatures risen? Well, by just over 0.6 of 1 degree Celsius since 1900. How can such a seemingly small rise create so much havoc with the planet's climate? Well, that figure, 0.6 degrees, is only an average. While some places have cooled a little, some, like the Arctic, have warmed by up to 3 degrees. Here, the frozen surface of the sea creates a highly specialized environment. And an extraordinary range of animals have evolved to live both above and below the ice. But the Arctic is now melting so fast that the whole intricate web of wildlife is under threat. And no species is more at risk than the animals at the top of the food chain, the polar bears. The turn of the year is when females give birth to and raise their cubs. By this time, mothers will not have eaten for many months, and yet they now have extra mouths to feed. Their main prey are seals, but they can only hunt before the ice melts. When it does that, they must come ashore with all the reserves they'll need to raise their cubs. And on land, there are no seals to hunt. Now, because the ice is melting earlier each year, mothers are going hungry and are less able to provide for their cubs. In Hudson's Bay, Dr. Nick Lunn sets out each spring to track down the polar bears and check on their health.
I've been working on the polar bears here in the Churchill area since the early 1980s, so over the last 25 years, and we're looking at the population ecology of polar bears in relation to climatic change. This population is the most studied population anywhere in the world.
By tracking the bears with such regularity, Nick Lunn and his team have discovered that their numbers have declined by nearly a quarter since he first started studying them. First, he needs to find the bears. He then tranquilizes them so that he can check their body weight to assess their health. The team has to work quickly to make their checks on the bear family before the mother wakes up.
24.5 pounds for cub one. On larger bears, we take the weight and their length and we calculate what we call a body condition index. It's essentially the weight of the bear divided by its length squared. And it gives us a means to compare bears between years, over years, what condition they're in when they come ashore. And we found that over the past 25 years or so that the condition of these bears is declining. Cub 2, straight line length, 0, 6, 9. Here we've got a female with a triplet litter. It's a very rare sight to find triplets in the fall time. One of the cubs is a runt of the litter. It's not likely to survive. 20 years ago, it wasn't all that uncommon to find triplets in the fall. About 5% of the bears we caught, or females with cubs, had triplets. We're seeing triplets born in the spring, but we're not, one or more of those cubs is not making it through to the fall. We're seeing reductions in cub survival, things of that nature, all related to climatic warming.
The ice is now melting 3 weeks earlier each year. That means that there is 3 weeks less feeding time for pregnant mothers.
And once they come ashore and the sea ice melts, the bears are forced to fast for anywhere from 4 months for most bears, up to 8 months for a female such as this bear here, who would have come ashore last summer and has not had a seal meal since last July.
If the current warming trend continues, the future looks bleak for polar bears. It's not just at sea level that the ice is melting at such an alarming rate. The global temperature rise is also being felt much higher up. Mountain glaciers all over the planet are also melting. The mountain ranges of Patagonia run down towards the southern tip of South America. This is the Neff Glacier in the northern Patagonian ice field. It starts almost 2,500 meters above sea level. This remote part of Patagonia is one of the coldest places on Earth outside the polar regions. Glaciologist Dr. Stephen Harrison has been working in locations like the Neff for 20 years. He's been studying how they've changed over that time.
The Patagonian ice fields are the most dynamic ice fields on Earth. To understand climate change in the southern hemisphere, we need to go to places like this. It gives us a very good record of climate change over the whole range of timescales. The ground I'm standing on, that glacier, the Neff Glacier, was here in about the 1870s. And by about the 1930s, it had retreated to this shoreline, the lake shoreline. And since then, since the 1930s, of course, it's retreated another 2.5 to 3 kilometers, perhaps 2 miles, back up its valley. When we were here in 1998, this whole lake was completely covered with icebergs. It was so thick with icebergs, we could hardly get our boat to the ice front. And yet that's all gone. That landscape has completely changed now. Glaciers give us a very visual record of climate change, and there should be no doubt that climate change is happening. If we look at what glaciers are doing all around the world, not just these ones on the North Patagonian ice field, but glaciers everywhere, they're all in recession pretty well. And that gives us a very visual record of what exactly is going on in the world's climate.
The rate of that glacier melt is now accelerating. In southern Greenland, the amount of ice flowing into the sea has doubled in the last 10 years. This is slowly but steadily causing sea levels to rise. "8,000 miles away, the inhabitants of the tiny Pacific islands of Tuvalu are already facing the realities of an invading sea. As temperatures rise, so do those of the sea, causing oceans to expand. And that, coupled with the glacier melt, means that sea levels will rise even higher. Earlier this year, tides rose to their highest level ever known, flooding the homes of the islanders. They have been troubled by this problem for the last few decades. But according to Diana Semi, it's getting progressively worse.
Most of the people now are experiencing this high tide is much higher than the 2001 and last year and the past years. If next year is going to happen like this and much higher than this year, then I don't think there's any future for Tuvalu.
Sumeo Silu is now Tuvalu's disaster coordinator.
The tide prediction for tomorrow is the highest, but now, looking at this time, it's flooded around. I feel sorry with them. All their properties, their agriculture, gardening, and all those will be damaged by this seawater. You can see that rubbish everywhere, and you already seen that the kids are swimming in, and those waste everywhere. I think a bit health problem with the kids, and especially these people staying in these houses, you know.
I'm very worried. The flood is coming there, the other door, coming outside, inside, but the flood is coming here. Years ago, my relatives say, here, and the tide is going down. But now this year, it's very, very high tide inside the house. This is the first time I think to move out because I'm afraid. But no place to move.
But on islands where the highest point is less than 5 meters above sea level, there is nowhere else to go. There are already plans for some of the population to be evacuated to New Zealand. But warming seas don't only mean rising seas. They have other implications too. In August 2005, Hurricane Katrina struck the coastline of Louisiana, Mississippi, and Alabama. It was the most destructive hurricane ever to reach the Gulf of Mexico. It created a storm surge that ravaged 100 miles of coastline. Was it the high sea temperatures that made Katrina so intense?
A typical hurricane starts as an atmospheric disturbance over Africa, but it's here in the Gulf of Mexico that they grow to their full destructive power.
Hurricane expert Greg Holland has been investigating what fueled Katrina's force.
The process requires that the oceans be warmer than about 26 degrees Celsius. The tropical clouds that get the hurricane started draw the energy from the surface high up into the atmosphere. And by this means, the ocean heat energy is used to fuel the development of the immensely powerful winds. And it is so powerful, it could run the entire electric grid of the United States for several weeks. The really destructive winds are in the region just outside the eye of the hurricane. And these are so strong, they shred the surface of the ocean into a morass of sea and spray that becomes so thick that it literally becomes impossible to tell the difference between air and water. And the warmer the tropical oceans, the more destructive the hurricane can become.
When Hurricane Katrina breached the levees of New Orleans, sea temperatures in the Gulf of Mexico and the Atlantic were the highest ever recorded. In the United States, the intensity and sheer destructiveness of the hurricane became the turning point in the debate about global warming. Although scientists will not say that one particular hurricane is caused by climate change, many are now making the connection between global warming, rising sea temperatures, and the increasing strength of hurricanes. "2005 was the worst season ever recorded." And Greg Holland is one of those who believes that worse is yet to come.
As you can see, there's a massive rebuilding program underway, but unfortunately this stretch of coastline will certainly be revisited by hurricanes like Katrina, and because of global climate change, they're going to be more intense, more destructive, and possibly more frequent.
It's a grim warning. But is global warming and the changes we're now seeing really a new phenomenon in the Earth's history? These days, when we talk of climate change, we tend to mean changes that we ourselves have brought about. But of course, the climate of the Earth has always been changing, either because of some great cosmic event, like a collision with a meteorite, or else because of some more slower, gradual change in the amount of energy that the Earth receives from the sun. It's the sun that provides our planet with warmth and light. But the amount of energy that the Earth receives from the sun varies. In cycles of tens and often hundreds of thousands of years, the Earth tilts and changes its orbit around the sun. And with each cycle, the patterns of light energy playing on the Earth changes. These natural changes have contributed to dramatic shifts in our climate. In the time of the dinosaurs, it was much warmer than it is now. You would have found dinosaurs roaming in forests close to the North and South Poles. 70 million years after that, much of our planet was freezing. It had become locked in a cycle of successive ice ages. If the city of New York had existed 160,000 years ago, it would have been on the edge of an ice pack some 2 kilometers high. And yet global temperatures were only 4 degrees lower than they are today. 30,000 years later, the same city would have been under 5 meters of water. Yet global temperatures were less than 2 degrees warmer than they are now. This seesawing in the Earth's climate was driven by natural forces long before mankind appeared. But there's another powerful influence on our climate that we have to take into account. Among the many gases that make up the air we breathe, there is one that is particularly important: carbon dioxide. It traps the sun's energy and so keeps the planet warm. Greenhouse gases, like carbon dioxide, act as a blanket around the Earth, preventing the sun's energy from reflecting back into space. It's called the greenhouse effect, and it's prevented the planet from freezing since the Earth began.
Without it, the global temperature would be minus 19 degrees Celsius. On the face of it, carbon dioxide seems to be a good thing. It stops our planet from freezing and so sustains life on Earth, and without it, no plant could grow because they need carbon to build their tissues. Leaves absorb the gas from the atmosphere through their pores. They then break down the carbon dioxide molecules, release the oxygen, and retain the carbon. Over hundreds of millions of years, the great forests took so much carbon dioxide out of the atmosphere that they reduced the greenhouse effect and cooled the planet down. When the trees died, they were buried, and over time crushed and compressed with the carbon still within them. In the ages that followed, these layers were slowly buried beneath the Earth's surface. At this open-cast coal mine in China, you can descend for 500 meters through layer upon layer of rock representing tens of millions of years. Right at the bottom lies a layer of what was once wood and leaves and is now coal and shale. It's an ideal place for Professor Bob Spicer to study the plants that influenced the climate all that time ago.
These leaves last saw the light of day some 50 million years ago when they were on the trees, taking in carbon dioxide and using the energy of the sun to fix that carbon into their tissues, leaves and twigs and the like. Now the original leaves had a cooling effect on the atmosphere because they were taking carbon dioxide out. And when we burn the coal and the carbon, oh, that's a nice one, and put it back into the atmosphere today, we have the opposite effect. We warm up the atmosphere.
Now, all the coal is being carried up to the surface to be burned in the power station, which provides electricity for hundreds of thousands of people. Oil and gas, like coal, are also fossil fuels. When such fuels are burned, the carbon recombines with oxygen and is released back into the atmosphere as carbon dioxide. The carbon dioxide spreads evenly through the Earth's atmosphere, thickening the greenhouse blanket that wraps the world and further warming the planet. That blanket extends for miles above the Earth's surface.
As you climb up away from the Earth, the gases become thinner and the temperature, as a result, becomes colder.
It was while I was making The Living Planet in the mid-1980s that I began to appreciate the crucial role of the atmosphere in shaping our climate.
We are very close to the top of our environment. For all the weather that goes on within these 5 brief miles, the envelope of atmosphere that wraps around the world, it's here that the weather is manufactured.
When I spoke those words, scientists were already detecting crucial changes in the composition of the atmosphere, in particular, changes in the level of carbon dioxide. All over the planet, they were recording rising levels of that particular gas in the atmosphere.
The first regular measurements were started 48 years ago from the top of the extinct volcano of Mauna Loa in Hawaii. And it is the rate at which the carbon dioxide blanket is thickening that is causing so much concern.
When I was a boy in the 1930s, the carbon dioxide blanket was still below 300 parts per million. This year, the thickness reached 382, the highest figure for hundreds of thousands of years. Every year, the blanket is getting thicker.
But how can we possibly know that carbon dioxide levels are higher now than they were thousands of years ago? In Patagonia's ice fields, huge gaps open up in the summer months, giving scientists a chance to investigate far below the glacier's surface. Stephen Harrison is taking the opportunity to descend deep into a crevasse in the glacier. It's risky, but glaciers are melting so fast that potentially invaluable records of the past are disappearing.
This ice cap from which these glaciers flow from is melting more quickly probably than any other comparable ice mass on Earth. You can see the amount of water which is around us.
Stefan has spent the last 20 years studying glaciers and past climates. He knows that ice can preserve valuable evidence.
Wow, look at this. The colour's amazing. Carbon dioxide is an important driver of climate change. In other words, it's an important factor in changing the globe's climate. You have to see how carbon dioxide has changed with the patterns of cold periods and warm periods throughout Earth's history. You can see the ice here is absolutely full of bubbles, and the bubbles were formed when the ice was formed. And of course the bubbles contain atmosphere, oxygen and carbon dioxide. If we want to understand the role of carbon dioxide as a thermal blanket over the Earth, we need to know about how carbon dioxide has changed, the concentrations have changed in the atmosphere over hundreds of thousands of years. An analysis of bubbles such as these in places like Antarctica and Greenland gives us that fantastic record.
That record is now also preserved thousands of miles away, not in the ice fields that originally contained it, but in Denver, Colorado. In this storeroom of the United States National Ice Core Laboratory, hundreds of thousands of years' worth of ice core records are maintained at -36 degrees. These ice cores have been extracted from as much as 3 kilometers beneath the polar ice caps. And for Professor Mark Serres, Each one provides a valuable source of information about a particular moment in the past.
Well, this particular chunk of ice is about 16,000 years old. It comes from the Greenland ice sheet. What we see here are layers of fossil snow. Every year on the top of Greenland there's an accumulation of snow, and this gets compacted year through year, layer after layer of snow, eventually to form these layers of ice. And it's within these layers of ice that we can tell all kinds of things about the Earth's past. What we find today is that the carbon dioxide concentrations in the atmosphere are higher than anything we've seen in the past 600,000 years. It's telling us that human activities are having a strong impact on the climate system. And if we measure this in parts per million of carbon dioxide in the atmosphere, what we call the pre-industrial level, before humans were starting to have an impact, was around 270, 280 parts per million. What we see now, the most recent records today are telling us that it's up to about 380 parts per million. So you can see that today's levels are far beyond anything that we've seen in the past. If you talked to me 5 years ago, I would have been kind of a fence sitter on this whole idea of greenhouse gases involved in climate change. No more. The changes that we've seen seem to be much too strong, much too radical to be just simply explained by natural climate cycles. What we're seeing now is the impact of humans. Humans are starting to change the climate itself. That's what we're seeing today.
Those changes could now be occurring even in places which are absorbing huge amounts of carbon dioxide. The Amazon is often referred to as the lungs of the world, for here plants take in vast volumes of carbon dioxide and give out oxygen. To appreciate the immensity of the greenery where this gaseous exchange takes place, you have to get up into the branches some 50 meters above the ground. I'm up in the canopy of the jungle, the tropical rainforest. Here there is a greater bulk of life, both animal and plant, and a greater diversity too, than can be found anywhere else at all. And this huge proliferation comes from two main causes, warmth and wetness. The wetness comes from the abundant equatorial rains, the warmth from the tropical sun. And between them, those two factors have created the jungle, which stretches in a broken green band right round the Earth. 20 years later, and in spite of intensive logging, vast areas of this forest still survive. But scientists like Dan Nepstad are uncovering an even more sinister threat to the health of the jungle than deforestation. He has discovered that many of the largest trees are dying.
What I think is, for me, the most scary part about the future of the Amazon is drought. Because when a drought comes, often with very little warning, it affects not just 1 or 2% of the basin. It can affect 30% of the forest in ways that we're just now learning can be quite devastating to the forest.
In 2005, the Amazon region suffered its worst drought in 60 years. The lack of rain led to a catastrophic fall in river levels, decimating the fish population. This year, 6 months after the drought, Dan Nepstad is finding that the trees have still not recovered.
Right now we're measuring how much water stress the tree that this leaf was growing on was under when we cut it. Last year's drought caught us all by surprise. It had devastating effects on the people who live in the Amazon. We're just right now getting a handle on how many hundreds of thousands of square kilometers of forest were severely damaged by drought killing enormous trees, which are the key organisms in these ecosystems. Could be that 2006 is a year full of forest fire because of the droughts of 2005.
The drought was linked to the abnormally warm seas in the Atlantic, which disrupted the rainfall patterns in the forests.
It's particularly worrisome because it's the type of ocean heating that seems to have caused the drought in the Amazon last year that is exactly what is predicted under a scenario of global warming.
But the Amazon is not the only rich ecosystem now at risk. The world's coral reefs are the marine equivalent of the rainforest, teeming with countless different species. Warming sea temperatures are already putting the oceans and the life within them under increasing strain. The 2,000-kilometre-long Great Barrier Reef in Australia is one of the wonders of the world. Early in the Life on Earth series, I examined it for myself.
The reef may look like some fantastic, multicolored jungle of plants and flowers, but when you touch one, it has the hard, incongruous scratch of stone.
Then, 27 years ago, the reef seemed one huge, unblemished and healthy world of its own. I described the intimate relationship between the tiny animal coral polyps and the algae that shelter inside them. A relationship established hundreds of millions of years ago that eventually produced reefs so immense that they're visible from space.
So it may well be that if a passing astronaut came this way several 100 million years ago, he might have noticed in the deep blue seas of the Earth a few mysterious, beautiful shapes in turquoise and guessed that life on Earth had really started.
But at the time I was making the series, I was unaware of a new and disturbing phenomenon: coral bleaching. Now, in early 2006, the state of the coral on the Barrier Reef is worrying marine biologist Ove Hogelberg. In recent years, he and other scientists have found that the reefs are far more sensitive to sea temperatures than they had previously thought. And this year, sea temperatures are abnormally high.
Everywhere I look, all I can see is bleached corals. Corals that are normally brown are now glowing a brilliant white. This is because of the algae having left the tissues. All that's left are the absolutely reflective skeletons. If I look down here, I can just see metre after metre of totally bleached corals. It's really quite striking. I don't think I've seen it really quite like this before. It's incredible.
What is particularly unsettling scientists is that this bleaching is becoming more frequent. If sea temperatures remain high for too long,
then the algae won't return and the coral may die. Ove Hogelberg is using a probe to discover how stressed this coral is.
And it tells me that most of the algae that are left in these corals are severely damaged. And they've been damaged by a combination of heat and light. When I come here and see this really stressed out reef, I find myself getting really concerned. It's another reminder that there are huge changes on the way with climate change. This is the third bleaching event in the last 8 years on the Great Barrier Reef. And as predicted, they're getting more frequent and more severe. And of course, personally, I find that rather frightening.
It's a devastating thought that if the warming continues, some of our richest environments and the species that live in them will be under threat. And it's not just the non-human world. We as a species will not be immune either. But how can we possibly know what the future holds? Scientists don't pretend that they can predict specific changes to the climate with absolute certainty. What they can do is calculate the likelihood that they will occur. It's here at the Met Office's Hadley Centre in Exeter that we can find the answer to some of the big questions. This supercomputer can perform 10 billion calculations per second, each one contributing to a model that scientists like Peter Cox can use to predict our future climate.
Climate models essentially have come out of weather forecasting models. They're run for much longer periods, they're run for hundreds of years rather than days, but they contain all the complexity. They contain clouds, they contain rainfall patterns, they contain winds, and climate models also have to contain slower components like how the vegetation and the soil respond to change and how the oceans change.
The model is like a virtual world, a sort of flight simulator, where everything from the melting ice in the Arctic to the formation of clouds in the atmosphere and the temperatures of the oceans are represented by formulae. It can give us the probability that future events may happen. For instance, what are the chances of our having another major heat wave like the one of summer 2003? And as the planet warms up, can we expect heat waves more often?
It's impossible to put any particular climatic or weather event down to climate change alone. But what you can do is say that climate change affects the chance of an event occurring. And the very extreme 2003 summer we suffered in Europe and killed many people in France, for example, is a case in point. That's something that is a rare event now. It's a 1 in 200 year type of event. But that is twice as likely as it was before we started to change the climate. And by 2040, because of future climate change, it will become a 1 in 2 year event, almost the norm. By 2080, we'll consider that a cool year.
One place where the Hadley model is predicting increasing temperatures is the Ningxia province in northern China. Not good news for a land where the desert is expanding. Over the last 20 years, there's been a marked decline in rainfall. Powerful winds have driven the thin soil into dunes, smothering fields and villages. In Bujing, many villagers have deserted their homes for the cities. those who are left behind, like Guanling, must endure a daily battle with the encroaching dunes.
There wasn't so much sand here before, but now the wind is blowing more and more sand into the village.
I remember when I was a child, the environment was really good. And in 1973, our fields went dry, the grass stopped growing, the dust storms came, the sand covered everything, and began to affect our lives in every way. When I get home, if I don't brush the sand away, I can't get into my house. This takes a lot of time, so it affects my work. There have been a lot of people who have left the village already. Well, they want to improve their lives, so they've moved to a better place with water and much better conditions.
Those villages that aren't swamped by sand are suffering from severe drought. This village, Sigo, has not had a harvest for 3 years. Professor Lin Erda is working for the Chinese government, trying to discover how badly affected the local people are.
Can you remember when you were young? Was it the same situation as today?
When I was a child here, it was also sometimes very dry, but it's become more serious in recent years.
How have the crops been recently?
The harvest was very bad.
Why was that?
There's been no rainfall. There's been no rain for 3 years. We can only depend on the food given by the government. And without crops, we have no income. We can't buy anything, and we have no money to spend.
When the winds pick up, the dry soil can quickly create a sandstorm. Such storms are already afflicting cities like Beijing. If the drying continues, this will only get worse. The bleak realities of climate change are being felt all over the world. And yet, despite so much evidence, some people refuse to believe that human activity is the cause of the changes we're seeing. The climate modelers at the Hadley Centre believe that they have proof. They factor both natural climate variations and our carbon dioxide emissions into their model to see which best explains the changes in temperature over the last 120 years. The key question, of course, is how can we distinguish between variations due to natural causes and those variations of the climate that are induced by human activity? And the key thing that convinced me, at any rate, was a graph like this one that we marked out on the floor that had been prepared from climate scientists like Professor Peter Cox. Now, explain to us the significance of this graph.
Okay, what we're going to do is to take a walk through time. And the first thing to note as we walk through is that the climate is naturally variable. It's a spiky beast. Occasionally there's a downward trend that's associated with a volcano going off that cools the system down because of the dust it throws up. But generally it just oscillates around. And then we get to a period around about 1910 where you can start to see an upward trend, a warming of the climate, a global warming if you like. And the issue is, what caused that? Was that humans or was that natural? So what we do to try and work that one out is to take a climate model and to put in the various factors. And what we can see with this green curve here is a climate model that includes just these natural factors. So this is when volcanoes go off and the output from the sun. And you can see that the green curve can reproduce reasonably well this mid-century warming. So up to this point, you could reasonably argue climate variation can be explained by natural factors. But as we move on, we can see that's no longer true as you get to the latter part of the 20th century. From about 1970 onwards here, you can see the red curve, the observed temperatures, and the green curve really beginning to diverge. And the question again is, what caused this recent warming? So we run the model again and we include human factors. Particularly we include the greenhouse effect, mostly from carbon dioxide that comes from fossil fuel burning. And then we get this yellow curve, and we can see, as well as reproducing the mid-century warming, we get this recent, rather rapid warming reproduced. And that tells us two things. One is that the model looks realistic, it looks like the real world. And the second thing, the model tells us that this recent warming is due to human beings.
So there you have it. There seems little doubt that this recent rise, this steep rise in temperature, is due to human activity. If you look at the green line of natural variability, it's clear that without the action of human beings, there would have been far less temperature change since the 1970s. We're all involved in this. Our whole way of life is structured around the burning of fossil fuels. I find it sobering to think that while I've been traveling the world trying to record the complexity and beauty of our planet, that I too have been making my own contribution to global warming. As I recognized when I presented Life on Earth all those years ago, we are a flexible and innovative species, and we have the capacity to adapt and modify our behavior. Now, we most certainly have to do so if we're to deal with climate change. It's the biggest challenge we have yet faced. This seawall was built to keep out what we recognized was a force of nature, something beyond our control. But now we ourselves have become a force of nature. We are changing the climate. And what happens next really is up to us. Next week, I will examine just how global warming could affect our future climate.
Of a day tomorrow. Again, the dry weather, the heat continues, so no relief from the drought in the southeast of England.
Could this vision of London come true if sea levels continue to rise? And I'll also be finding out more about what we need to do to save planet Earth.